Grounding conductors, such as the number 2 copper THHN, cannot be run through a building, even above a suspended ceiling, without being installed in a conduit or raceway. Article 250.118 of the National Electrical Code dictates that grounding conductors and bonding jumpers must be installed in a raceway or otherwise protected from physical damage. The primary reason for this requirement is to ensure the safety and reliability of the grounding system. Firstly, physical protection is paramount. Grounding conductors are susceptible to damage from various sources within a building. This can include accidental contact with sharp objects, impacts from dropped equipment, or even damage from rodents. A conduit or raceway provides a robust barrier that safeguards the conductor from these potential hazards, maintaining the integrity of the grounding path. Secondly, maintaining a low impedance path to ground is crucial for effective fault current clearing. If a grounding conductor is damaged, its ability to conduct fault current is compromised. This can lead to elevated touch potentials on equipment enclosures and increase the risk of electrical shock. A properly installed conduit or raceway ensures that the grounding conductor remains intact, providing a reliable low impedance path for fault currents to flow back to the source. Thirdly, minimizing electromagnetic interference is also an important consideration. Running a grounding conductor without a grounded metallic raceway can contribute to electromagnetic interference. The raceway acts as a shield, reducing the amount of electromagnetic radiation emitted by the grounding conductor, which can interfere with sensitive electronic equipment. Fourthly, compliance with the National Electrical Code is not optional. The NEC is a widely adopted standard that sets forth the minimum requirements for safe electrical installations. Failure to comply with Article 250.118 can result in code violations, fines, and potential liability in the event of an electrical incident. Fifthly, consider the different types of raceways suitable for protecting grounding conductors. These include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The choice of raceway depends on the specific application and environmental conditions. For example, rigid metal conduit offers the highest level of protection against physical damage, while flexible metal conduit is useful for connecting to equipment that is subject to vibration or movement. Sixthly, proper installation practices are essential for ensuring the effectiveness of the grounding system. This includes securely fastening the conduit or raceway to the building structure, using appropriate fittings and connectors, and ensuring that all connections are tight and properly made. Improperly installed conduits or raceways can compromise the integrity of the grounding system and create potential safety hazards. Seventhly, understand the purpose of a grounding conductor. It is intended to provide a low impedance path for fault current to return to the source, allowing overcurrent protective devices such as circuit breakers or fuses to quickly interrupt the circuit and prevent electrical shock or fire. Eighthly, the size of the grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. The National Electrical Code provides tables that specify the minimum size of the grounding conductor based on the ampere rating of the overcurrent device. Ninthly, consider the different types of grounding conductors. These include equipment grounding conductors and grounding electrode conductors. Equipment grounding conductors connect the non-current carrying metal parts of equipment to the grounding system, while grounding electrode conductors connect the grounding system to the earth. Tenthly, regularly inspect the grounding system to ensure that it is in good condition. This includes visually inspecting the grounding conductors, conduits, and raceways for any signs of damage or corrosion. Any damaged or corroded component should be replaced immediately to maintain the integrity of the grounding system. 11thly, recognize that grounding is not the same as bonding, although the terms are sometimes used interchangeably. Grounding refers to connecting the electrical system to the earth, while bonding refers to connecting non-current carrying metal parts of equipment together to create a low impedance path for fault current. 12thly, it is important to note that the National Electrical Code is updated periodically to reflect changes in technology and best practices. It is therefore essential to stay up to date with the latest edition of the NEC to ensure that electrical installations comply with the most current requirements. 13thly, understand that the rules regarding grounding conductors also apply to bonding jumpers. Bonding jumpers are used to connect different metal parts of equipment together to create a low impedance path for fault current. 14thly, the size of the bonding jumper is determined by the size of the equipment grounding conductor. The National Electrical Code provides tables that specify the minimum size of the bonding jumper based on the size of the equipment grounding conductor. 15thly, consider the different types of bonding jumpers. These include wire-type bonding jumpers and strap-type bonding jumpers. Wire-type bonding jumpers are typically used for connecting small pieces of equipment, while strap-type bonding jumpers are used for connecting larger pieces of equipment. 16thly, proper installation of bonding jumpers is crucial for ensuring the effectiveness of the grounding system. This includes securely fastening a bonding jumper to the equipment, using appropriate fittings and connectors, and ensuring that all connections are tight and properly made. 17thly, recognize that grounding and bonding are essential for electrical safety. They protect people from electrical shock, prevent equipment damage, and reduce the risk of fire. 18thly, it is important to consult with a qualified electrical contractor when installing or modifying electrical systems. A qualified electrical contractor has the knowledge and experience to ensure that the installation is safe and compliant with the National Electrical Code. 19thly, the National Electrical Code provides specific requirements for grounding and bonding in different types of occupancies, such as residential, commercial, and industrial. These requirements vary depending on the specific hazards present in each type of occupancy. 20thly, understand that the grounding system is only as good as its weakest link. Any damaged or improperly installed component can compromise the integrity of the entire system. 21stly, it is important to regularly test the grounding system to ensure that it is functioning properly. This can be done using a ground resistance meter, which measures the resistance of the grounding system to earth. 22ndly, the National Electrical Code requires that all electrical equipment be properly grounded. This includes appliances, lighting fixtures, and other electrical devices. 23rdly, the purpose of grounding electrical equipment is to provide a low impedance path for fault current to return to the source, allowing overcurrent protective devices to quickly interrupt the circuit and prevent electrical shock or fire. 24thly, consider the different types of grounding electrodes. These include ground rods, ground plates, and concrete to encased electrodes. The choice of grounding electrode depends on the soil conditions and the specific requirements of the installation. 25thly, the National Electrical Code provides specific requirements for the installation of grounding electrodes. These requirements include the minimum size and depth of the grounding electrode, as well as the location of the grounding electrode. 26thly, proper installation of grounding electrodes is crucial for ensuring the effectiveness of the grounding system. This includes driving the ground rod to the proper depth, connecting the grounding electrode conductor to the ground rod with a listed connector, and ensuring that the connection is protected from corrosion. 27thly, recognize that grounding is an essential part of a comprehensive electrical safety program. It works in conjunction with other safety measures such as overcurrent protection and ground fault circuit interrupters to protect people from electrical hazards. 28thly, it is important to educate yourself about electrical safety. This includes learning about the hazards of electricity, how to prevent electrical accidents, and what to do in the event of an electrical emergency. 29thly, the National Electrical Code is a complex document that can be difficult to understand. It is therefore important to consult with a qualified electrical contractor or electrical engineer when designing or installing electrical systems. 30thly, remember that electrical safety is everyone's responsibility. By following safe electrical practices, you can help to protect yourself and others from electrical hazards. 31stly, while specific circumstances may warrant alternative methods, it is always best practice to adhere to the NEC guidelines to maintain the highest level of safety and code compliance. The requirement for physical protection of grounding conductors as mandated by Article 250.118 aims to mitigate risks associated with damage, ensure effective fault current clearing, and promote overall electrical system reliability.